Okay, let's look at question number 2 of the 2023 AP Calculus AB exam. This was not a common question with the BC students, and I am reading this question for the first time, so you get to see me solve it and analyze the problem in real time. So I do not have a pre-made solution. Oh, Stephen, my good friend Stephen. I had Stephen in once. Okay, so Stephen is swimming back and forth along a straight path in a 50-meter long pool for 90 seconds. Stephen's velocity. So they give you a particle motion question. That was one of my predictions. Okay, cool. Okay. So I'm going to start by going to my calculator and I'm going to store this function for v of t. So I'm going to define v of t to equal 2.38 e to the negative 0.02t. That needs to be multiplied by the sine of pi over 56. Pi over 56 t. Double check, make sure everything is in there correctly. 2.38 e to the negative 0.02 t, sine of pi over 56 t. That is all in there correctly. Double check that you are in radian mode. You definitely don't want to solve any of this in degree mode. That would be disastrous. And let's start solving. Oh, pay attention units also. So we're in seconds and meters. Okay, so find all the times t at which Stephen changes direction and give a reason for your answer. So my game plan for part A, changing direction, we need v of t to change signs. So we're going to do this graphically. And if velocity changes signs, let's see, this would be a continuous function because velocity is a composition of exponential and trig functions, or the sine function, and both of those are continuous. So v of t changes signs. I'm going to start by finding out when the velocity is equal to 0, and I solve all my equations graphically. Even if you do have a nice sexy calculator like the Inspire CAS, you want to avoid using the solve command. So I'm going to go to my graph screen. I'm going to graph the function v of x. You must use x in the graph screen, and that is okay. What is my time interval? For 90 seconds. We're going from 0 to 90, so I need to go menu, analyze graph, not analyze. I need to change my window settings to go from 0 to 90. And I guess I'll leave my y's where they are. Yeah, that's fine. Looks like we are only changing direction once. I need to analyze those zeros. So menu, analyze, 0. And there is my solution right there. A nice, clean, sexy 56, which I guess makes sense because sine of 1 pi would be 0. Okay. So t equals 56. Normally I solve my solutions here, but that's a nice integer. So v of t equals 0 at t equals 56. And technically at t equals 0 as well. If you look at the graph, it does look like it's starting at the origin. And if you analyze the graph, if you analyze the equation, if you plug in 0, you can't see it, but if you plug in 0 for t, you would have sine of 0, which does equal 0. Now, since that's an endpoint, it's not going to end up factoring into the solution. So I can tell that based on the graph, we're going to change direction at time equals 56, but we always want to give an explanation for how we're coming to that conclusion. And so essentially we're doing that little number line trick for velocity. I know that velocity is 0 at 56. I need to verify that velocity does indeed change signs. So I'm going to find my velocity at any point left of 56. You can pull a random number. Usually I pick something sexy like 0, but since this is a calculator question, I'm just going to plug numbers into the calculator. So let's do v of 20 and v of 60. So I'm going to go back to my calculator here, and I'm going to actually type in what is v of 20 and what is v of 60. And I got a positive followed by a negative. Now you have to actually write that on paper. So I'm going to actually say v of 20 is, and that value was 1.437. That is a positive value, which means my velocity is positive on the left side, which we knew graphically, but we have to use math language explaining how we know that. V of 60 was negative 0.160. That is less than 0. and velocity is negative. Do keep in mind that the number line is 100% invisible. It does not count as any work shown. So you want to have sufficient math language written outside your number line to justify any explanations. And these inequalities right here, my velocity is positive, my velocity is negative. That is my work supporting my statement. And my answer is Stephen changes directions only at t equals 56. And I'm going to type this for the sake of time. At t equals 56 because velocity v of t changes sign at t equals 56. And I guess I'll say seconds. Here we go. And there's your answer for A. Pretty nice question. Let's go on to B. Find Stephen's acceleration at time 60. Stop and answer that. That's a very easy question because acceleration is the derivative of velocity. Now you have to show that you understand that we are doing the derivative of velocity. So if you only wrote a of 60 equals whatever the answer is, you may not get that point. I need to show that I understand that acceleration is the derivative of velocity. And now I'll go to my calculator and we'll use that trusty derivative at a point command. Menu, calculus, derivative at a point. I'm using the variable t. T is 60, the first derivative of v of t, and I got negative 0.036. Okay, so there is the acceleration. Show the setup for your calculations. And then show the setup for my calculations. It's a calculator question. I guess that is the setup for my calculations. Boy, I wonder how many students dove into like product rule and chain rule, and oh my gosh. All right, but there's my answer now. Units would be, let's see, we're in meters per second for velocity. Yes, so this would be meters per second squared. And I think that little, it's kind of nice. Show the setup. They're prompting you to show the relationship between velocity and acceleration, like I did right there. So that's what they're trying to do. Is Stephen speeding up or slowing down? Okay, speeding up or slowing down is dependent on whether the velocity is also positive or negative. So we have to analyze the sign of both velocity and acceleration. So now I'm going to find the velocity at 60. And that is negative 0.160. So V of 60 is negative 0.1. It was actually 1595, wasn't it? Which gives you the option of rounding. Technically on this one, you don't have to go to the third decimal because our answer is not the actual velocity. It's whether velocity is positive or negative. And if you simply wrote velocity at 60 is negative 0.2, that would be enough to support your answer. But I kind of like to go 3 decimals. So is speed increasing or decreasing? Their words are speeding up or slowing down, and give a reason. Speed is, go back to typing for the sake of time. Stephen's speed is increasing because acceleration at 60 and velocity at 60 have the same sign. Both are positive, negative. Ooh. Okay, and so there is our answer for part B. Cool. Number C, find the distance between Stephen's position at time 20 and his position at time 60. Show the setup for your calculations. Okay, so we're looking for displacement. The distance between those positions, they don't care about your back and forth motion. They do say that Stephen is swimming back and forth, but they simply want to know, where is Stephen at 20, where is Stephen at 80, and what's the distance between those 2 points. They're not asking about the action that happens between those two. And displacement on a certain interval is going to be the definite integral from 20 to 80 of the velocity. And if you think, I'm going to erase this, but if you think about the antiderivative of velocity, that would be his position, which I'll use the function x for position. And then you would evaluate that at 80 and 20. And so if you find the position at 80 and the position at 20 and you subtract those two, you get the distance between those 2 points. However, we don't need to show that much work. I'm simply going to throw this in a calculator and write down the answer. Shift plus, and we're going from, it was 20 to 80 of my v of t function, dt, and I'm getting 23.3839. 23.3839, which you can round to 0.384 or truncate to 0.383. In this case, you do need that third decimal because this is the answer to the question. And my Chromebook that has the questions just shut down and I have to log back in. Dun, 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 dun. Okay. Show the set, find the distance. They did not indicate to include units. If you want to include units, that would be in meters, but that was not requested. So I'm kind of being a itty bitty bit risky there. But whatever. All right. Find the total distance. He swims over the interval. Okay, so total distance. These questions are nice. These are nice questions. Total distance is 20 to 80. No, it's not. No, it's not. This is 0 to 90. The total distance is the antiderivative of the magnitude of velocity. The magnitude of velocity. And we'll throw that in the calculator. Nice questions. I would say that both of these calculator questions are quite nice indeed. I am surprised at the lack of a rate in, rate out. They may have put that on the non-calculator part. I don't know yet. As I've told you, I haven't read the questions yet. The absolute value of v of t. Enter 62.164 meters. So that would be 62.164 meters. Again, you don't have to throw in units. And show the setup for your calculations, find total distance. Maybe I'm going to double check my calculator on that one, make sure I got the right decimal value. And it does not round up, so we would just stop there. And there's your question number 2. So 2 very good questions. I would say that those are quite nice, predictable questions for the free response section on the AB. We'll see what the non-calculator holds for you.